Greetings, Algebra 2 Honors students. This video on graphing general functions is brought to you by the Monkey and the Elephant Cafe at 29th and Girard Avenue in Philadelphia. The Monkey and the Elephant is a nonprofit cafe that raises money to support young people who have aged out of the foster care system. It's a very delicious cafe with very delicious coffee. Regardless, we have here one problem to do, to graph a quadratic function. In particular, y equals negative, it did say on your paper just negative x squared. I changed that to negative 1x squared. They mean the same thing. Plus 2. The only thing you have to really keep in mind when doing this packet is, well, just how to use the domain and how this is going to affect the graph. But to get a little bit ahead of ourselves, I want you guys to understand that, okay, this is a quadratic function. All quadratic functions are some transformation of the parent quadratic function, just like all cubic functions are some transformation of the cubic parent. All right? Here's the parent quadratic. So think about it. Y equals positive x squared is the parent. Now, this is getting changed in two ways. First of all, we're throwing a negative in front, and then we're also adding 2 to the end. So if we start with y equals x squared, if we make it y equals negative x squared, meaning negative 1, times x squared. We're multiplying all the y values after squaring x, right, because of PEMDAS. After squaring x, we're then multiplying all those values by negative 1. And that's what y is going to equal. So originally, where all the y values had to be positive because we were squaring x, if we drop a negative 1 in front, we multiply by negative 1, that's going to mean all the y's are now going to be negative. So that's going to be the new graph. That's y equals negative 1x squared. Okay? Because again, you're going to be squaring an x value, but then multiplying it by negative 1, so it's going to become negative, or 0. All right? But not only that here, we also have a plus 2. So if we add 2 to the end, that's just going to take all those values, all the y values here, and shift them up 2. We're going to add 2 to the y values. Okay? So the new graph is going to look like this. It's going to start up there, have what's called a vertex at the point 0, 2, and then it's going to go down like this. Okay, so it's a parabola that opens down and has a vertex at 0, 2. That's going to be the graph that we're going to want to draw. But we're only considering this graph on the domain from negative 3 to 3. I know in your paper it was written as an inequality, but to remind you from class, if we're between negative 3 and 3, inclusive of the two endpoints, we use brackets. We can write it in interval notation like this. All right? So we're graphing this function, but only between negative 3 and 3, meaning we're going to have to just cut this off where x is negative 3, and cut this off where x is 3, and the entire graph is going to look like this. Okay, that's going to be generally our graph. But let's see that up here. Okay, so now that we know what it should look like, it's going to be a parabola, or a piece of a parabola, that's been flipped over the x-axis and then shifted up too. So a good idea here, guys, is to certainly find the endpoints. So plug in negative 3 and plug in 3 to the function, and see what we get for y. So for negative 3, y equals negative 1 times negative 3 squared plus 2. We end up getting negative 3 squared is positive 9. Write this down here. So we get negative 1 times positive 9 plus 2. This is negative 9 plus 2 is going to be negative 7. So we have one point is definitely going to be negative 3, negative 7. That's one of these endpoints. If we plug in 3, same thing's going to happen. We have negative 1 times 3 squared plus 2. Which is again negative 1 times 9 plus 2, which is negative 9 plus 2 is negative 7. So we also have 3, negative 7. Okay, I've just plugged in those endpoints individually to find out where our graph's going to end left and right. So negative 3, negative 7. Here's negative 3, and then there's 7 boxes here, so this is tough to do by hand, but there's going to be at point negative 3, negative 7, and then one point over here, a mirror image at 3, negative 7. We have those 2 points. Those are going to be as far left and as far right as our graph will go. All right, I graphed it larger up here, but you will have those 2 points there. And then we also want to find some points in the middle. Now, I mean, we know what the shape's going to look like because I just showed you, right? But let's just find some points, sort of filling in a table. All right, so let's. We've already got the negative 3. Negative 7, 3, negative 7. How about 0? How about one more for good measure? Negative 1, 1. So we plug in 0 for x. It's going to wipe out this whole term. We're left with 2. Plug in 1 for x. Well, 1 squared is 1, times negative 1 is negative 1 plus 2 is 1. And the same thing would happen with negative 1. Negative 1 squared is 1. 1 times negative 1 is negative 1 plus 2 is 1. So here are 5 word pairs. We already have 2 of them graphed. 0, 2 we already knew. And then 1, 1, and negative 1, 1. And now we have enough to see that shape. You can find more points if you'd like. In this particular graph, you should have some symmetry. My graph is not perfect, because I did it by hand on the board. Right? But this is the way the graph should look. Now, it doesn't have arrows at the end. Okay, I know the original function does. It does go down forever. But you're only graphing the parabola, which does go down forever. But you're only graphing it on the domain negative 3 to 3, which means, okay, you're going to stop it where x is negative 3. X is not going to be any less than that. And x is not going to be any more than 3. Now, the type of domain I give you might vary. If I said, okay, instead of negative 3 to 3, if I said one more restriction, if I said negative 3 to 3, but only integers, so only integers only, or something like that, then you would actually have to just draw a bunch of dots, right? Because if there's a continuous graph here, that implies that decimals can work, fractions can work, and irrational numbers can work for x. But if you're restricted to only integers, we would have to fill in more of a table. We'd have to also consider the other 2 values, which we haven't found yet, negative 2 and positive 2, which would give us, 4 times negative 1 is negative, 4 plus 2 is negative 2. Both would be negative 2. So that's pretty accurate, actually. Not this one, it'd be out there. But our graph then would not be continuous. It would just be a series of dots. Okay, just those 7 dots. All right? It all depends on what kind of domain I give you. I could throw you curveballs, you know? I mean, again, if it's going to give you, just restrict you to integers, it's just going to be these 7 points you're going to plot. Only the integer values for x. Maybe it says only whole numbers, and that erases even more. That erases the negatives, right? Whole numbers are only positive. Maybe it said only natural numbers. That would get rid of this one, you know? There's many different kinds of problems I could give you, all right? But just a little heads up for what we're going to get into. Have a good day.